Hi everyone, in this video I will talk about the concept of central limit theorem. Central limit theorem. Okay, so what central limit theorem states is that as your sample size n goes to infinity, right, as your sample size gets big, your sample distribution will become a normal distribution. And again, the reason we want to work with normal distribution is that normal distribution is easy to work with, it's very convenient, and we can use our z-table to do our calculations. Okay, easy to use, and we can use z-table. But now the question is, under central limit theorem, as n goes to infinity, the distribution will approach normal distribution. But how large n has to be, right? So the question is, how large we need n to be to have normal. Okay, so that's the question we want to ask. And this really breaks down into two situations, right? Two situations. So the first case, the first scenario, if your population distribution, right? So if the population you're picking from, if the population distribution is normal, so the population itself is a normal distribution, then n doesn't have to be very large. Right, so n not very large. Okay, but if your population distribution is not normal, so the second scenario is your population distribution is not normal, it's not a normal distribution, then we need n to be fairly large. We need n to be fairly large. Okay, so what does it mean to have population to be not normal? And as your n is very large, then you get your normal distributed sample distribution. Okay, well, so what it means here. So let's say we have three population distributions. So population. So with three population distributions. Okay. And say x1, right? The first variable. See, the distribution is like this. Okay. It's just totally random. It's definitely not normal, right? So it's normal here, normal here, normal here, but the whole thing is not normal. Or x2, you know, the distribution something like this, right? So this one's missing, so this part's missing. Or if you just like a line here, okay? So as you can see, all these three, they're not normal distributed, so the population distribution are not normal. But under the central limit theorem, okay, but as n gets fairly large, the distribution of your x bar, your sample mean, the distribution of sample mean by the central limit theorem, it will become something like this. It's like a smooth normal distribution, right? So if you apply the central limit theorem, even though your population distribution is not normal, but as your sample size gets large, very large, you'll be able to get a sample distribution to be, sample mean distribution to be smooth normal. Okay, good. Okay, so let me give you some results of the central limit theorem. Okay, so again, our sample mean x bar is a random variable. Okay, so we know this. It's a random variable by the central limit theorem. By the central limit theorem. As n goes to infinity, okay, our x bar sample mean is normally distributed. And the expected value of our x bar should equals to the population mean here. So after the normalization, as sample size gets really big, then the expected value of our sample mean is equals to the population mean. Okay, next. Okay, so next we need to talk about the variance of x bar. But here, let's say sigma x bar. Okay, what I'm denoted here is the standard deviation of our sample mean, right? So it's the sample mean standard deviation, but we call this standard error. Okay, so the standard deviation of our sample mean is our standard error, and this equals to the population standard deviation divided by the square root of our sample size. So this is the population standard deviation. This is our sample size. Well, for now, we assume that we know the population standard deviation, and we'll get deeper into the case where we don't know this one. But the formula under the central limit theorem is this one. This is the result that the central limit theorem will give you. Okay, good. Yeah, so this is one, and this is the second one. Okay, two results of the central limit theorem. Okay, very good. So this video concludes the concept of central limit theorem. Thank you for watching. I'll see you in the next video.